The basic system design for Viessmann systems and zoning and mixers has been discussed a few times recently on the forum. It is actually very, very simple, but I think worth going over just for the benefit of some people seem to be struggling with it a little bit. So basically the Viessmann 200 can be used as either a 4-pipe or a 2-pipe boiler. It's designed to be a 4-pipe, has a diverter valve. I think it's on the return now, can't remember. Not sure it's on return or the flow, but it doesn't really matter, it's a diverter valve. And basically it's priority hot water. There's a thermistor from the cylinder into the boiler, and if the boiler sees a time program for heating the hot water and it sees a temperature below the set temperature, it'll basically operate the diverter valve, go into full output, and deliver the full output of the boiler to the cylinder, obviously modulate back depending on return temperature. We say that on return temperature, but it doesn't have a return sensor. Basically it's looking at flow temperature, but the return temperature will cause it to modulate back in order to add the correct amount of energy in to achieve the right flow temperature. So I hope that helps that. Controlled by return temperature, but focusing on the flow temperature. I think I said that right. Okay. So once hot water is heated, it will then look for demand down the system. Now the Viessmann 200 can run multiple circuits. I think as standard from the box it can run 2 mixed and 1 unmixed circuit, and you have to add an additional control if you want to go beyond the standard 3 circuits. So for my designs, normally the unmixed circuit will be the highest temperature circuit, and this allows the motorized valves, the motorized blending valves, to reduce the temperature in the other floors or other zones. If the highest temperature demand is one of these zones, the valve will be pretty much fully open and the boiler will be firing at the flow temperature of the circuit with the highest temperature demand. So this unmixed circuit normally radiators, and these mixed circuits are normally looking at underfloor heating zones, but you could use them on radiator zones, etc. And that's really it. So these are no different to an underfloor heating zone in effect. If you look at the design, these are actually drawn as underfloor heating zones. We have our flow coming in, going through the mixing valve, hitting a pump, going through the underfloor manifold pipework and back, and there's a return off here to recirculate the return water. In the Viessmann drawings there is this bypass drawn in on many of them, and I think the idea of that is that it controls the maximum amount of water that can be drawn in from the flow, so that if you know, so let's say you've got a flow rate of 20 litres a minute on this circuit and we're always drawing 10 litres back, the maximum it's going to draw in from the circuit here is going to be 10 litres. So we've got some way of controlling the volume of flow in this secondary circuit, and I think that's mainly used when you don't have a low loss header. So in this diagram I've drawn the low loss header and I've drawn the bypass, so this is a little bit of a grey area for me. I believe it's for when you don't have a low loss header, but I would pretty much always install the low loss header. So that's it. Purpose of the low loss header generally is that you would have underfloor heating here, and we don't want these systems to clash with each other or clash with the flow rate of the boiler. And the general rule from Viessmann is that if the flow of the system is going to exceed the maximum flow of the boiler, then to use hydraulic separation, which could be close coupled T's or low loss header, or could be a plate heat exchanger. So that's it really, fairly straightforward. You've got the option to have these multiple different control systems. The one thing you need to bear in mind with these systems when you're designing them is the size of pipework on the communal area. So on traditional high temperature underfloor heating systems, the pipes could be sized based on your delta T20 along the system because you're delivering high temperature water to the underfloor. But on a low temperature system, these pipeworks have to be designed to take the full flow rate of the underfloor heating system, which is normally designed on delta T7. So be very careful of that, not to undersize these pipes, especially on bigger systems. Normally on most domestic systems, any standard manifold up to 12 loops would be pretty much served by 22 mil. So it shouldn't really be an issue. Sizing of the common pipework here, the distribution header is important. You don't want to induce any flow through any of these circuits, so the resistance in this circuit should be low, and this draws the flow through the low loss header. So, okay, I hope that helps. Any questions, just post them up.